Yes, it is possible for someone to receive a slight shock if their hands are wet. Wet hands can decrease the body's electrical resistance, allowing a small current to flow if there's contact with a live electrical source. An inspector should verify that a ground fault circuit interrupter, or GFCI, is installed and functioning properly. The electrical outlet location should be checked to ensure that the outlet is not positioned in a wet or damp area. Wiring and connections should be examined to ensure that all wiring and connections are secure and in good condition. Grounding should be confirmed to ensure that the outlet is properly grounded. There may be a design error if the outlet is located in a hazardous location, such as a wet or damp environment. Outlets should not be placed within 3 feet of a sink or other water source. Outlets should not be positioned where they can be easily accessed by individuals who may come into contact with water or other conductive materials. The National Electrical Code, or NEC, Section 406.8, states that outlets in wet or damp locations shall be GFCI protected. NEC Section 406.8 B states that receptacles installed in locations where they may be exposed to moisture shall be of a listed type for such locations. NEC Section 210.52 D states that GFCI shall be installed in bathrooms. NEC Section 406.4 states that receptacle outlets shall not be located within reach of a bathtub or sink. Let's delve deeper into each of these aspects to provide a more comprehensive understanding. First, let's discuss ground fault circuit interrupters, or GFCIs. A GFCI is a crucial safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing in a circuit. If it detects any imbalance, even a very small one, between the outgoing and incoming current, it quickly trips the circuit, cutting off the power. This imbalance often indicates that current is leaking to ground, potentially through a person touching a live wire or a faulty appliance. GFCIs are particularly important in wet or damp locations, such as bathrooms, kitchens, and outdoor areas, where the risk of electric shock is higher. Secondly, regarding electrical outlet location, the placement of electrical outlets is a critical factor in preventing electrical hazards. Outlets should never be installed in locations where they are likely to come into contact with water or moisture. The NEC specifies minimum distances for outlet placement from water sources, such as sinks and bathtubs. These distances are intended to prevent water from splashing or coming into contact with the outlet, which could create a shock hazard. In general, outlets should be located at least 3 feet away from sinks or other water sources. Furthermore, outlets should be positioned in a way that they are not easily accessible to individuals who may have wet hands or be in contact with conductive materials. Thirdly, let's examine wiring and connections. Proper wiring and secure connections are essential for electrical safety. All wiring should be in good condition, with no exposed or damaged insulation. Connections should be tight and secure, preventing loose wires that could create sparks or short circuits. An inspector should carefully examine the wiring and connections of the outlet to ensure that they meet safety standards. Any damaged or loose wiring should be repaired or replaced immediately. Fourth, we need to address grounding. Grounding is a critical safety measure that provides a path for electrical current to flow back to the source in the event of a fault. A properly grounded outlet helps to prevent electrical shock by providing a low resistance path for current to flow to ground, tripping the circuit breaker or GFCI. An inspector should verify that the outlet is properly grounded and that the grounding system is functioning correctly. If the outlet is not grounded, it should be corrected immediately. Fifthly, hazardous locations need to be determined. A hazardous location is any area where there is an increased risk of electrical shock or fire. Wet or damp environments are considered hazardous locations because water can conduct electricity, increasing the risk of shock. Outlets should never be installed in these locations unless they are specifically designed for use in wet or damp environments and are GFCI protected. The NEC provides detailed guidelines for the installation of electrical equipment in hazardous locations. Now let's break down the specific NEC references. NEC Section 406.8 covers outlets in wet or damp locations. It requires that all outlets installed in these locations be GFCI protected. This requirement is intended to prevent electric shock by quickly cutting off power in the event of a ground fault. NEC Section 406.8 B addresses receptacles installed in locations where they may be exposed to moisture. It requires that these receptacles be of a listed type for such locations. Listed receptacles are specifically designed and tested for use in wet or damp environments and are constructed with materials that resist moisture and corrosion. NEC Section 210.52. D specifies that GFCI shall be installed in bathrooms. This requirement is intended to protect individuals from electric shock while using electrical appliances in the bathroom, where water is commonly present. NEC Section 406.4 states that receptacle outlets shall not be located within reach of a bathtub or sink. This requirement is intended to prevent individuals from touching an outlet while they are in contact with water, which could create a shock hazard. In addition to these specific NEC references, there are other relevant sections of the code that may apply depending on the specific circumstances. These include sections that address the installation of electrical equipment in hazardous locations, the grounding of electrical systems, and the selection and installation of wiring and overcurrent protection devices. When conducting an inspection, it is important to consider all relevant NEC requirements and to ensure that the electrical installation meets all applicable safety standards. The overall goal is to create a safe electrical environment that protects individuals from electric shock and other electrical hazards. A thorough understanding of the NEC and proper installation practices are essential for achieving this goal. Let's further discuss the importance of maintaining proper clearances around sinks and water sources. The 3-foot rule, while a general guideline, is crucial in preventing accidental contact with electricity. Imagine a scenario where someone is washing their hands and water splashes onto the wall. If an outlet is located too close to the sink, the water could easily come into contact with the outlet, creating a conductive path for electricity. This is especially dangerous if the outlet is not GFCI protected. The GFCI acts as a rapid response system, detecting any leakage of current and immediately shutting off the power. This prevents a sustained electric shock, which could be fatal. However, even with a GFCI, it is still important to maintain proper clearances to minimize the risk of water splashing onto the outlet in the first place. The placement of the soap dispenser is also relevant. If the soap dispenser is located directly next to the outlet, it increases the likelihood of water and soap residue accumulating around the outlet. This can create a conductive environment and increase the risk of corrosion, which can further compromise the safety of the outlet. It is best practice to locate the soap dispenser away from the outlet, providing a buffer zone to prevent water and soap from coming into contact with the electrical components. Furthermore, the type of receptacle used is also important. In wet or damp locations, it is essential to use a listed receptacle that is specifically designed for such environments. These receptacles are constructed with materials that resist moisture and corrosion, and they are designed to prevent water from entering the electrical component. They are also often equipped with covers or other protective features to further minimize the risk of water damage. The height of the outlet above the sink is another factor to consider. While there is no specific NEC requirement for the height of outlets above sinks, it is generally recommended to install them at least 6 to 8 inches above the sink line. This helps to prevent water from splashing onto the outlet, and it also makes the outlet less accessible to children. However, even at this height, it is still important to maintain proper clearances and to use a listed receptacle that is designed for wet or damp locations. The condition of the outlet itself is also important. Over time, outlets can become worn or damaged, which can compromise their safety. Cracks, loose connections, and other signs of wear and tear should be addressed immediately. A damaged outlet should be replaced with a new, listed receptacle that is designed for wet or damp locations. Regular inspections can help to identify potential problems before they become serious hazards. During an inspection, it is important to check the outlet for any signs of damage, corrosion, or loose connections. The inspector should also test the GFCI to ensure that it is functioning properly. If any problems are found, they should be corrected immediately. It is also important to educate individuals about the risks of electrical shock and the importance of electrical safety. People should be aware of the potential hazards of using electrical appliances in wet or damp locations, and they should know how to properly use and maintain electrical equipment. Simple steps such as wiping out spills immediately and avoiding the use of extension cords in wet locations can significantly reduce the risk of electrical shock. In the specific case of the school bathroom, it is important to thoroughly investigate the incident and to take steps to prevent similar incidents from occurring in the future. The school should conduct a comprehensive electrical safety audit to identify any potential hazards and to ensure that all electrical installations meet applicable safety standards. The audit should include a review of the placement of outlets, the condition of wiring and connections, the grounding system, and the GFCI protection. Any problems that are identified should be corrected immediately. The school should also provide training to staff and students on electrical safety. This training should cover the risks of electrical shock, the proper use of electrical equipment, and the importance of reporting any electrical hazards. By taking these steps, the school can create a safer environment for everyone. In addition to the technical aspects, it is also important to consider the human factors that may have contributed to the incident. For example, was the individual wearing shoes with good traction? Was the floor slippery due to soap or water? Was the individual distracted or in a hurry? Addressing these human factors can help to prevent future incidents. The school should also review its policies and procedures for maintaining the bathroom to ensure that it is kept clean and safe. This may include regular cleaning of the floor, prompt cleanup of spills, and regular inspections of the electrical equipment. By taking a comprehensive approach that addresses both the technical and human factors, the school can create a safer environment for everyone. The role of the inspector is crucial in ensuring electrical safety. A qualified electrical inspector has the knowledge and experience to identify potential hazards and to ensure that electrical installations meet applicable safety standards. The inspector should conduct a thorough inspection of the outlet and the surrounding area, paying close attention to the placement of the outlet, the condition of the wiring and connections, the grounding system, and the GFCI protection. The inspector should also test the GFCI to ensure that it is functioning properly. If any problems are found, the inspector should provide recommendations for correcting them. The inspector should also provide guidance on how to prevent future incidents. It is important to choose a qualified and experienced electrical inspector. The inspector should be licensed and certified, and they should have a thorough understanding of the NEC and other applicable safety standards. The inspector should also have a good reputation and a proven track record of providing quality inspections. By choosing a qualified and experienced electrical inspector, the school can be confident that the inspection will be thorough and accurate. Furthermore, it is important to maintain records of all electrical inspections and any corrective actions that are taken. These records can be used to track the safety of the electrical system and to identify any recurring problems. The records should be kept in a safe place and should be readily available for review. In summary, electrical safety is a complex issue that requires a comprehensive approach. By addressing the technical and human factors, by conducting regular inspections, and by maintaining proper records, the school can create a safer environment for everyone. The NEC provides a comprehensive set of guidelines for electrical installations. It is essential to follow these guidelines to ensure that electrical systems are safe and reliable. The NEC is updated regularly to reflect the latest technological advancements and safety standards. It is important to stay up to date on the latest changes to the NEC and to incorporate them into electrical installations. In addition to the NEC, there are other applicable safety standards that may apply depending on the specific circumstances. These include standards from organizations such as the National Fire Protection Association, or NFPA, and the Underwriters Laboratories, or ALL. It is important to be aware of these other applicable safety standards and to comply with them. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring that electrical systems are safe and reliable. By working together, we can create a safer environment for everyone.